Are you ready to dive into the fascinating world of dispersion measures? If you haven't subscribed yet, hit that button now so you don't miss out on our amazing content. Don't worry, dispersion might sound intimidating, but I'm here to make it fun and easy to understand. Let's get started. Imagine you're holding a bag of colorful marbles. Dispersion tells us how spread out those marbles are in terms of their different colors. In statistics, we use numbers to describe and understand the world around us. Dispersion measures help us understand how data points are spread out from the average or mean. Just like those marbles, data can be tightly packed together or widely dispersed. We'll be exploring three key dispersion measures: variance, standard deviation, and range. From understanding test scores to analyzing weather patterns, dispersion measures play a crucial role in various fields. First up, let's tackle variance. In simple terms, variance measures how much individual data points differ from the average. Think of it as the surprise factor. A high variance means the data points are scattered far from the average, like a group of kids with wildly different shoe sizes. Imagine you're tracking the number of cookies your friends eat each week. Let's say the average is 5 cookies. If some friends eat 2 cookies and others eat 8, that's a bigger variance than if everyone stuck close to the average. To calculate variance, we find the difference between each data point and the average, square those differences, add them up, and then divide by the total number of data points. For the denominator, if it is the population variance, then we use n, but if it is a sample variance, then it is n1. It sounds complicated, but don't worry, we'll break it down in our interactive exercise later. Review the concepts of population and sample if you need them. Now, let's move on to standard deviation, which is simply the square root of the variance. Why do we need both? Well, variance gives us a squared value, which can be hard to relate to our original data. Standard deviation brings it back to the same scale as our data, making it easier to interpret. Think of standard deviation as the average surprise factor. It tells us how much, on average, each data point deviates from the mean. A low standard deviation means the data is clustered closely around the average, while a high standard deviation indicates a wider spread. For example, imagine you're measuring the height of sunflowers in your garden. If the standard deviation is small, it means most of your Last but not least, we have the range, which is the simplest dispersion measure to understand. It's simply the difference between the highest and lowest values in a dataset. Think of it as the spread from the smallest to the largest value. Let's say you're recording the temperatures throughout a week. The range would be the difference between the hottest and coldest days. A large range means there's a big difference between the extremes, while a small range indicates a more consistent temperature throughout the week. While the range gives us a quick snapshot of the spread, it doesn't tell us much about how the data is distributed within that range. That's where variance and standard deviation come in handy. Now it's time to put your knowledge to the test. Let's calculate the variance, standard deviation, and range. Our dataset is the number of candies in 5 different bags: 10, 12, 12, 14, 16. Step 1. Calculate the mean average. Add all the numbers together and divide by the total number of bags: 10 plus 12 plus 12 plus 14 plus 16, divided by 5 equals. Step 2. Calculate the variance. First, find the difference between each number and the mean. Square each of those differences. Add up all the squared differences. And finally, divide the sum by the total number of bags. Step 3. That was it. Please don't forget to subscribe. You have more to learn. Do not forget, by understanding basic concepts like dispersion measures, you gain the ability to analyze data, identify patterns, and draw meaningful conclusions. See you in the next video.